Okay, so today we're going to continue with our organic molecules and our naming. So our syllabus outcome is investigate nomenclature of organic chemicals up to C8 using IUPAC conventions, including simple methyl and ethyl branch chains, including alkanes, alkenes, alkynes, alcohols, aldehydes, ketones, halogenated organic compounds. So this time we're going to do most of the stuff, so it's going to be quite long. It is going to be complex, but we'll take our time, just make sure we get all of these rules down pat, because it's the same rules over and over again. So let's go. Quick revision: hydrocarbons are organic molecules consisting of only carbon and hydrogen atoms. Alkanes have only carbon and hydrogen atoms linked by single covalent bonds. Alkenes have at least one double carbon-carbon bond. And alkanes have at least one carbon-carbon triple bond. Now, we need to start having a look at substituents. So these are things that we can place on the parent chain. So it's an extra atom or carbon chain that's attached to the parent chain. Most common are halogens, or what we call alkyl groups. So they're more carbon chains. So more ethyl groups, more methyl groups. So here's some examples. So basic substituents are the halogens. So fluoro, chloro, bromo, and iodo. So these are the names that we give to those substituents when they're on a carbon chain. That should say substituent in the third column. But if we have an extra CH3 or a CH2CH3, these are our alkyl substituents. So a methyl is just an extra CH3 on the chain. An ethyl group is an extra CH2CH3. Propyl is CH2CH2CH3, so on and so forth. Now the syllabus only says methyl and ethyl, but we'll include a few propyl, butyl ones just for completeness. Okay, so you only need to know those first two. Now, how do we name a compound with substituents? Well, we need to be very specific and very exacting with our naming, because if we don't name it right, then we're actually naming a different compound. To name an organic molecule with substituents, we follow these rules. Firstly, identify the longest carbon chain. This is our parent chain, and it forms the basis. So is it a hexane? Is it a heptane? Is it a pentane? What is it? We find the longest one. Now, it's not always going to be drawn in a straight line, and that's the key thing to remember, is that we need to just find the longest regardless of how it's drawn. We identify the type of chain. Is it an alkane, an alkene, or an alkyne? We identify the substituents on the parent chain. So what is there? Is there a chlorine group? Is there an extra methyl group? Is there an iodine? What's in there? We need to identify it. We then need to number the substituents in such a way as to be the lowest total number. And if there's more than one type of a substituent, we add di, tri, tetra in front of the name, and we put the numbers for where all of those substituents are. Okay, now you'll pick it up as we go, but the key thing is just to remember those 5 basic rules. Okay, 6 basic rules. I forgot one. If there's more than one type of substituent, the substituents are listed in alphabetical order. So for example, ethyl comes before methyl, chloro comes before fluoro, so on and so forth. So if we remember those 6 rules, we should have no problems. Now, we start. First step is identifying the longest carbon chain. So here there's 4. 4 is what? It's bute. So it's a butane chain. Okay? We then identify things that are hanging off the chain. So here we have a CH3 group that's hanging off the chain. And that's a methyl group. Okay? We then have to do numbering of it, but we'll get to that in a sec. So let's have a look. Longest chain is 4 carbons, so it's a bute. They're all single bonds, so it's a butane. There's one substituent that's a methyl. Now, which carbon's it on? It could be on carbon 2 or carbon 3. But we want to take the one with the lowest number, so we're going to put it on 2. Okay, so we're going to number it as number 2. It's on carbon number 2, so we put the name together. The first thing we do is we say it's 2-methyl butane. That's how we write it. So we don't leave a space, or we don't put a dash between the methyl and the butane, but we put a dash between the number and the substituent. Okay. If it follows on from another substituent, we put a dash between the first substituent and the second number. Okay, we'll do an actual example of that shortly. But yeah, we make sure we put the dashes there. There's no spaces except with acids. So no spaces, dashes only between the numbers and the words. So 2-methyl-butane. Here we've got something very similar. What's the longest carbon chain? Well, I can count a chain of 4. What have we got hanging off it? There's 2 CH3 groups. So, longest chain is 4 carbons. It's a bute. What type of bonds are they? Well, they're all single bonds, so it's a butane. There's 2 substituents that are both methyl, and they're both on carbon number 2. Now, when we're numbering them, we need to specify that they are both on carbon 2. So the way we put it together, we do number, comma, number, dash, name. So they're both on carbon 2, so it's 2, 2, dash, dimethyl butane. And that's how we name that one. If there was one on number 2, one on number 3, it'd be 2, 3 dimethyl butane. Okay. If there was 2 on 2 and 2 on 3, it'd be 2, 2, 3, 3 tetramethyl butane. Okay, so that's how we figure those out. We need to number every single one of them. Here's a different one. Okay, our basic longest carbon chain is 3. Anything else hanging off that chain? Yes, there is. Oh, there's also a carbon-carbon double bond. There's a chlorine hanging off it. So we kind of have to start putting this together. We start with the longest chain. It's 3 carbons, so it's a pro. We have 1 double bond, so it's an ene. Now, which carbon does that double bond belong to? Well, we like to number it so it's the lowest. So we're going to say that that's on carbon 1 to carbon 2. Okay. We have a chlorine, so we call it a chloro substituent. And it's on carbon 2. Now, the way that we name it, firstly, we do the number for the chloro substituent, so it's going to be 2 chloro, prop 1 ene. Okay, so see how we got that? So the double bond, so the ene is on the carbon number 1, chloro is on carbon number 2. Okay, and it's a prop because we've got 3 carbons. What about this one? What's the longest carbon chain you can see? Well, I can see 5 in a row there. Now, we have 2 substituents and we have a double bond. So that double bond's at the end, and we have 2 carbon substituents. So 2 methyl groups. Longest chain is 5, so it's going to be a pent. We have a double bond on the first carbon, so it's going to be pent 1 ene. We have 2 substituents that are both methyl. One's on carbon 2, one's on carbon 3. So, putting it together, the name, what do we think it's going to be? It's going to be 2, 3 dimethyl pent 1 ene. Okay, so again, seeing how we've got the dashes and commas, there's no spaces in any of that. Now, we need to discuss a little bit about functional groups. These are some other groups that we can add in that change the parent compound. So it changes it from an alkane, alkyne to an alcohol, or a carboxylic acid, or an amine, or whatever. Okay, it changes the fundamental name of the compound. Now, functional groups, it's an atom or a group of atoms bonded in a particular way that has similar chemical properties whenever it appears as part of a larger compound. So, for example, acids, the acid group, it's a functional group. Whenever it's found in a molecule, it will donate a proton. Okay, That's what we mean by similar chemical properties. All of the alcohols, hydrogen bonds, so they're more likely to be soluble in water. Okay, so they're those chemical properties that when they appear, like when these functional groups appear, give that molecule that chemical property. Functional groups we've come across so far are the alkenes and the alkynes. Both of these react in specific ways. Okay, so that's the same chemical property. So whenever we see a double bond, it's going to react with bromine water, for instance. Okay, and it will brominate a double bond or a triple bond. And so that's how we get those particular things. Now, when naming organic molecules, I've put this big and bold. The primary functional group is always assigned the lowest possible number, and it will always make up the longest chain. It won't always make up the longest chain, but we need the longest chain to include that functional group. Okay, so if we have an alcohol, we need to find the longest chain that contains the alcohol. Now, what's an alcohol? It's what we call a hydroxyl group. It's literally just an OH that's bonded to the end of, or it's anywhere within our molecule. Molecules that contain that OH group end in -nol, so ethanol, methanol, propanol, butanol. Now, the chemical property is that whenever we have an OH present, we can get hydrogen bonding occurring. Okay, and therefore the alcohols are usually soluble in water. Now, let's name this compound. We do the same thing. We find the longest chain that contains the OH. Okay, so we can see there's an OH there. The longest chain that has the OH in this case is 3, and the OH is there right in the middle. So longest chain is 3, so it's a prop. One substituent that is a hydroxyl group, so it's going to be an enol. It's on carbon number 2. So the name is propane 2-ol. Okay. Now, why do we say propane 2-ol and not just prop 2-ol? Well, we have to just define that there's all single bonds. So we can see that there's just single bonds present. Otherwise, it'll be propene 2-ol. Okay, prop 2-ene 2-ol, something like that. So we need to define that. So it's propane 2-ol. Naming this compound. Now this is where we start to have to trace the longest chain around a corner. So we can see that you might be instinctually inclined to just say, this is 3, this is a propanol. Well, no, the longest chain that has the OH attached to it is actually 4 carbons. So it's actually a butanol. We have an OH. What's left? We have a CH3. So we've got a methyl group on our alcohol. So longest chain is 4. It's going to be bute. They're all single bonds, so it's going to be a butan. We have a hydroxyl group. It's on the 2nd carbon. So at the moment, we got butan 2-ol. We also have a methyl group. It's on carbon number 2. So it's going to be 2-methyl butan 2-ol. Okay. So again, looking at that naming convention, it's going to be the same for everything else. Okay, just follow the rules. Make sure you write it correctly. What about this one? What's our longest carbon chain? 5. Okay. We also have an OH attached. We have a bromine attached. Now, we need to start naming it. Now, our OH, we have one OH, so it's going to be pentanol. And it's on carbon number 1. So again, with our primary functional group, we like it to be numbered so that that functional group is the lowest. Okay, so regardless of where our OH is, it's going to be numbered the lowest. So it's on number 1, which means we have a bromine that's on carbon number 4. So how do we put it together? Well, we number the bromine as 4, so it'll be 4-bromo. Pentane 1-ol. 4-bromo-pentane 1-ol. Okay. Aldehydes, another functional group. The functional group for aldehydes is what we call a carbonyl group. Now, a carbonyl group is a carbon-oxygen double bond. Now, because oxygen has 2 bonds, nothing else comes off the oxygen. Only 2 other things can come off that carbon because it's got 2 bonds. Aldehydes specifically are always on the end carbon. So this is one of those rare ones where we don't need to number the functional group because it's at the end. And it ends in -anal. So F-anal, prop-anal, butanal. Again, no numbers needed because it's always at the end. So name this compound. So we follow the same rules. Find the longest carbon chain. Boom, 3. Okay. We have a look at the functional group. It's a carbon-oxygen double bond. And it's at the end, so it's an aldehyde. Also using the context of we're talking about aldehydes. We also have a fluorine there in the middle. So how do we put it all together? 3 carbons, it's going to be a prop. It's got a carbonyl at the end of a chain, so it's going to be an anal, so it's going to be propanal. We also have a fluorine that's on carbon number 2. So this one's going to be 2-fluoropropanal. Okay, so again, the 2-fluoro comes from the fact that fluorine's on the second carbon, and we've got that carbon-oxygen double bond at the end of the chain. Now, naming this compound. This one's going to be a bit of a doozy. Let's have a look at it. What's the longest chain that we can see? Well, it's actually this. It's a hex. Yeah, 6. So it's got 6 carbons in the longest chain. So this is what I mean by it's not always going to be drawn straight. It can go around corners. Okay, if they want to be difficult, they can draw it this way. What else is on there? Well, it's got that carbon-oxygen double bond at the end of the chain. So it's going to be an anal, so it's an aldehyde. We also have a methyl group further down the chain. So we've identified everything. Now we put it together. Longest chain is 6 carbons, so it's a hex. It contains a carbonyl at the end of the chain, so it's going to be hexanal. And there's a methyl substituent on the 3rd carbon. Okay, so it's going to be 3-methyl. So putting it all together, 3-methyl hexanal. Another one. What's the longest carbon chain? 1, 2, 3, 4, 5. I can count. Now, this is where it gets a bit tricky. The longest chain is actually 6. Okay, we can actually see it. I'll put on the laser pointer. Okay, 1, 2, 3, 4, 5, 6. But we have a carbon-oxygen double bond. That is our functional group. So when we're counting the longest chain, we want the longest chain that includes that functional group, which in this case is actually just 5. So those 5. What else is on there? We have our carbon-oxygen double bond identifying it as an aldehyde because it's at the end. We also have 2 carbons. So it's a CH2CH3. So that is an ethyl group. So put it together. Longest chain is 5 carbons. And I'll put the asterisk there because it's the longest chain that includes the functional group. So it's 5 carbons, so it's pent. Contains a carbonyl at the end of the chain, so it's pentanal. And on the second carbon, there is an ethyl substituent. So CH2CH3 makes it an ethyl group. So therefore, the name is 2-ethyl pentanal. So even though it looks like a kind of complex molecule, the name is quite simple. Now, ketones. Ketones can also contain a carbonyl group, but it's not at the ends. So it's not on the terminal carbons. It's in the middle. The name ends in -none. So methanone, actually no, there's no methanone. Propanone, butanone, hexanone. The numbers are needed to show which carbon it is. Except for propanone, as there's only one option, because there's only one middle carbon. For something like butanone, it's going to be 2-butanone. Okay, we need to specify that. So name the following compound. Find the longest chain that contains the functional group. So in this case, the functional group is our carbon-oxygen double bond. The longest one that contains that is 5, so it's pent. I've messed up the animations on this slide, but you'll get over it. It contains a carbonyl that's not at the end of the chain, so it's an unknown. So at the moment it's pentanone. The carbon is on, sorry, the carbonyl, so our carbon-oxygen double bond is on the second carbon. So it's pentane 2-one. And we also have a methyl group on the third carbon. So in this case, it's 3-methyl pentane 2-one. What about this one? Longest carbon chain is 5. Carbon-oxygen double bond is on the third carbon. We also have a chlorine. Now, which carbon is that chlorine coming off? Well, yeah, it's carbon number 1. So remember, we can number right to left or left to right. It doesn't matter. It doesn't matter the direction as long as the numbers are the lowest possible. So we can have 1 chloro or we can have 5 chloro. Which one's lower? It's 1. So pent, anone, carbon's on 3, so it's pentane 3-one with a chloro substituent on carbon number 1. So it's 1 chloro, pentane 3-one. What about this fancy one? Longest carbon chain is 1, 2, 3, 4, 5, 6, 7. So it's a hept. So it's a heptanone because it's got that carbon-oxygen double bond. We also have a fluorine partway along the chain. Now remember, when we're numbering it, realistically, you can think of this 2 ways. There's 2 ways to possibly number this. We can have it as 6-fluoroheptane 3-one, or we can have it as 2-fluoroheptane 5-one. Okay. Now the first way, the numbers are higher than the second one, but we need our functional group to be the lowest number. So in this case, it's going to be heptane 3-one with fluorine on the 6. So it's going to end up being 6-fluoroheptane 3-one. Okay. Now, summary. Substituents are atoms attached to the parent chain. Substituents can include halogens such as fluoro, chloro, bromo, iodo, or other carbon chains such as methyl or ethyl. Now, alcohols, they have an OH functional group, so a hydroxyl group. Whenever they're in a molecule, we name the molecule an enol, so ethanol, propanol, butanol. Aldehydes have a carbon-oxygen double-bonded functional group at the end of the parent chain, and they form enals. So methanal, ethanal, propanal. Ketones have a carbon-oxygen, so that carbonyl functional group is elsewhere in the molecule, so it's not at the end of the parent chain. And we can start with things like, and it's named with enone, so it's things like propanone, butanone, pentanone, hexanone. Okay, so go through now, try and answer those questions. Just follow those 6 rules. They're the most important part. Just follow those rules iteratively. Just go through them over and over again in order. And if you follow those rules, you'll be able to name them well. Okay, so get to it and thank you.